Okay, so hello everyone, and welcome to ESBAAR webinar on long-range drone for pipeline inspection. My name is Ibrahim Masoudi, and I will be your co-host today, inshallah. I am joined by our main speaker here, Petrus. He is an expert in the utilization of drone technologies for industrial applications. Also, Petrus has extensive experience in the drone industry for almost 9 years, and his insights for sure will be invaluable today, inshallah. So, in this webinar, we will go through the exciting world of long-range drone, which also called BVLOS, Beyond Visual Line of Sight, and its application in the pipeline inspection. We will explore the benefits of using drones for this purpose. Then we're going to discuss the latest advancements in the field, and also we're going to answer any questions you may have. So if you have any questions during the presentation, please type them into the chat box in your Teams. And then we will have a time at the end of this webinar to answer the questions at the end, inshallah. So now, without any further ado, I would like to hand over the floor to Petrus to take us through the presentation. Petrus, are you ready?
Hi, Ibrahim. Yes, thank you so much. I am ready.
All right. The microphone is yours then.
Thank you very much. Let me just switch on my camera there. Good morning, everyone. Thank you for joining us today. I do understand we're all very busy, but hopefully we'll all walk away from this today and learn something new. Like Ibrahim said, my name is Petrus. I am a expert in the field of drone operations as well as aviation operations in general. And the purpose of today's webinar is to share some insights into the use of long-range drone technology in specifically in the oil and gas industry. But as you will see throughout the webinar, the applications are limitless and not necessarily confined to only the oil and gas industry. If you have any questions, please feel free to pop them in the comment box, and we will address them at the end of the webinar or at the end of the presentation. So if everybody's ready, we're going to get started. Again, welcome. Oh, geez, there we go. All right. Just to take away some ambiguity and talk about some of the terms that I'll be using today. When I refer to the term BVLOS, it, like Ibrahim stated, it means beyond visual line of sight. Essentially, that just means flying the drone to a point where the pilot no longer has visual contact with the aircraft. When I use the term UAV or RPAS, I'm simply referring to drones. So please don't get confused. And again, if you need any clarification, please feel free to pop your questions in the comment box. Moving on. So the purpose of today's presentation is specifically in regards to the use of drones in the inspection of pipelines. And as for those of you that are involved in the oil and gas industry, the high cost of pipeline failures is phenomenal. Apart from being devastatingly expensive in terms of fiscal outlay, they're also very detrimental to the overall operation of the company. We're talking anything from plant shutdowns to interruptions in supply of gas and oil, not even to mention the impact on the environment, which can not limited only to the actual damage to the environment, but also the fines involved from various environmental agencies in regards to oil spills, gas leaks, etc. So as we can all imagine, it gets quite expensive. And worst of all, the biggest impact that we have when it comes to pipeline failures is the safety aspect, not just to the environment, but also to people and animals. So it's very important for us to be able to maintain a system where we can quite effectively manage and inspect our oil and gas infrastructure to make sure that unnecessary failures don't happen. So what are the limitations of traditional methods? Traditional methods can be anything from people on foot walking next to pipelines. More traditionally, it's, especially here in Oman, it's done using vehicles. driving alongside the pipelines. This is extremely time consuming, not to mention it's extremely expensive. Due to labor costs, the effects of the logistics of the deploying crew to remote locations. This just doesn't just include the actual driving next to the pipelines, but also includes the accommodation required, the meals, things like that. So in terms of logistical and fiscal outlay of traditional inspection methods, it's becoming unsustainable, to be quite honest. But it is unfortunately one of those things that needs to be done, because if we don't, we saw what the effects could be of having failures. Now, let's talk a little bit of some of the small advantages, as well as the big advantages of using drones in lieu of traditional methods. Now, when we talk about drones, we have two fields of study. Now, the first one is VLOS, which is visual line of sight, which I will not go into in too much detail. And then we have BVLOS, which is beyond visual line of sight, like I mentioned earlier. Now, the traditional methods for pipeline inspection, such as ground patrols, come with significant drawbacks. Now, ground patrols can be slow, tedious. They take days, sometimes weeks, to inspect extensive pipeline networks. This translates, like we said, to higher labor costs and logistical challenges of deploying the crews to remote locations. Now, BVLOS drones offer a solution that overcomes these limitations. They enable the collection of data in a safe manner by keeping personnel out of hazardous environments, such as rugged mountains, dense forests, very hot deserts, active drilling sites, active construction sites, etc. So BVLOS drones can, however, cover very vast distances in a single flight. This significantly reduces the inspection times compared to traditional methods. Furthermore, they offer a cost-effective solution. They minimize manpower requirements. They minimize the requirements to deploy ground crews. In some cases, BVLOS inspections can even help avoid the need for complete pipeline shutdowns, saving additional time and, for some people, more importantly, money, which is, as we all know, the one thing that makes the world go round. So BVLOS drones provide us with safe data collection, like we said, efficient inspections, and cost-effective solutions. Now, VLOS drones also have their place in the industry. VLOS drones allows for deployment and inspection to very small, concentrated areas, allowing the operator to cover, I would say, larger areas compared to traditional methods, but still have that sense of having your eye on the problem, if everybody is with me on that one. Now, let's talk about BVLOS drones as a game changer in the industry. Now, BVLOS drones address the limitations of traditional methods by offering a safe, efficient, and cost-effective approach, like we said before. They also eliminate any risk to personnel by enabling the inspections to be done from a remote location. In the case of our operation, the guys sit in a very, very nice, very well-appointed, air-conditioned room while they operate and fly. So in terms of choosing between that or in the middle of the desert in the middle of the summer, I think we all know what choice we would make, to be honest. So another advantage, I wouldn't say really advantage, another aspect to the use of BVLOS drones rather than traditional methods is that the data that we collect is not limited to only visual inspection of assets. It also can be compiled and concatenated into various other aspects, be they orthomosaic mapping, topographic mapping, real-time imaging of the area that you operate. These data sources allow management and people in the planning departments to more effectively manage and plan for future developments as well as long-term maintenance plans. So the data isn't just limited to a guy looking at a screen or a camera looking for problems, leaks, etc. It's also the data can be used afterwards with real-world metrics and real-world effects on how you operate your business and how you operate your maintenance planning and your construction planning. Now, let's talk about some of the risks that we eliminate. The risk that we eliminate to personnel in hazardous environment is the inspection of pipelines in rugged mountain areas, dense forest, active drilling sites, deserts. These all come with inherent risks, which are too many to list in such a small period of time. But as we who work in the oil and gas industry on a daily basis know that the safety and the risk factor is the first and foremost priority for everyone. We want to eliminate any hazard or potential injury to people on the ground, and also to assets at the same time. Another thing that we have that allows us to be a little bit more efficient when we use drones, it enables us to do inspections in roughly a 24-hour period. We are not limited to daylight operations only. At night, the use of thermal imaging cameras and LiDAR for data acquisition is also a real world boon to the industry. And again, the data used there is not necessarily only for inspection purposes, but also high resolution image orthomosaic maps, real-time topographic changes. These are all data that the various departments require to plan correctly. So why are BVLOS drones effective? Well, in terms of vast distances that we cover, we traditionally fly anywhere upwards of 800 to 1,000 kilometers a day in our current operation. In a small 6 to 8 hour window, we cover extremely vast distances with very high levels of accuracy and high levels of safety, obviously. We have been fortunate enough to minimize the downtime for our clients in regards to potential risk factors like leaks, breaks, rust, corrosion, damage from foreign debris, etc. So we are able to identify potential problems and hazards before they even manifest and become a problem. And then we can quite accurately direct the maintenance teams, the labor teams to the exact location, to within a 5-meter point of accuracy, to the problem areas. Whereas traditionally somebody would have been required to actually physically see the problem area by eye. And as we know, humans do tend to miss things, especially if we get tired and fatigued. Now, the big saving that we always like to tell people is the reduced cost of manpower. Now, the biggest bill for any company is normally the salary bill, as we all know. And by using BVLOS drones specifically, you are cutting your manpower requirements by a significant percentage. Now, this percentage will obviously differ from company to company, but it is to an extent where you can see real world savings in your overall operational costs. And the last point that I want to make before we move on is the cost of logistics. You have one team located at a central location with central requirements versus having mobile teams that require constant updates, constant support, constant changes to schedules and criteria, travel arrangements, meals, accommodation, etc. These are all things that you cut from your overall logistics costs, and they do, as we all know, make a very big dent at the end of the month. Now let's talk about some of the payloads and some of the uses of the data that we have from BVLOS drones. Now, in our case, we use high resolution data acquisition. These come in the form of photogrammic cameras that take very high resolution still images. At the same time, our drones are equipped with what we call pods, which are FMV cameras, which are monitored and manipulated by the payload operator on the ground. These have very high resolution, very high zoom levels where we can identify problem areas, zoom in, we can take still images of the area, and immediately provide a report to the client with a accurate location, accurate time, an accurate summary of what the issue is, or at least what the payload operator thinks the issue is, and thereby allowing the client to make use of their own internal systems and decision-making processes to address the issue in a timely manner. So we are cutting the overall time between acquisition of a problem area to actionable maintenance or repairs to be done by about 70%, which is quite substantial, if we're honest. But again, we're not limited to only cameras. We are, in the past and even now currently, we have been able to fit our drones with LiDAR sensors for topographical surveys, OGI sensors for gas detection and quantification, in terms of looking for gas leaks, because as we know, some gases are colorless and odorless. We have special payloads that are able to pick up these gases in the ultraviolet spectrums and quantify the leak and the type of gases that's actually escaping from pipes, wells, wellheads, etc. Furthermore, ESBAAR is, apart from drones, we are first and foremost a artificial intelligence company. We specialize in the use and development of advanced AI tools, specifically in the areas of oil and gas. So our data is automated to the sense where the AI is used to detect, scanning through thousands and thousands of images to look for specific problems in terms of leakages, cracks, corrosion, moving a little bit away from pipelines. At the same time, our AI is able to detect road infrastructure anomalies, especially here in Oman, where we have extensive sandstorms and issues with sand encroachment on national roads. This is another service that our drones, at the same time, while doing pipeline inspections, we do pick up these anomalies and we report them to the relative authorities in a very timely manner. So we use AI-powered algorithms extensively for detection. These AI tools detect the problems, they flag them for review by a human eye, and thereafter the reports are sent to the relevant client, to the relevant department. But the reports can have no superfluous data. The reports are concise, to the point. This is the problem. This is the problem area. This is what we think you should do. Please take action in accordance with your internal procedures. And these happen within minutes of detecting the problem, at most, sometimes within 24 hours. Now, the next question that I know some of you might have is, well, how does a BVLOS operation look? How does it happen? Well, it's fairly simple. We have pre-flight planning. It starts normally the previous month or the previous week, where in conjunction with the client or with the experts, we decide on a flight plan. What does that entail? That entails us talking to the relative authority or the relative client and discussing which areas he would like inspected, which pipelines do they think, pipelines or roads or power lines, do they think require the most amount of maintenance or is scheduled for maintenance for that week. So what we then do is we plan our flights to overfly specific areas, specific assets over a specific period of time. These flight plans are very, very comprehensive. They include anything from weather planning to solar radiation, because they have also, solar radiation has an effect. We look at crew availability, we look at maintenance, all of that. So this is a very detailed part of the procedure. After the pre-flight planning is completed, we're going to deployment and what we call data acquisition or data collection, which is quite simply put in layman's terms, we deploy the drone takes off. We fly the predetermined flight path in conjunction with how the client would like it done. We acquire the data, both real-time and saved on board the aircraft. Once the mission is completed, the aircraft returns to base, it lands, the data is taken from the aircraft, sent to the data processing systems, be it AI or human being influence. And after that, we have reports sent to the client. Now, I would just like to play a short video for everyone to see some of just a little bit of sample data of how effective real-time surveillance using drones in the oil and gas industry can be. There's no sound involved in this video. This video is taken at an altitude of about 500 meters above ground and circling the asset at about 500 meters in terms of radius. This is real-time thermal imaging as well as full color spectrum video. This is a standard flare stack inspection. As you can see, the detail is quite clear. Now, you might ask yourself, what is the advantage of this? Here we have a video of an inspection of the oil rig. Now, again, what is the advantage of this? Well, the advantage is you don't need people on the ground to do this. This can be done from a remote location by somebody sitting in a safe environment where we minimize the risk as well as the overall time required to do these inspections. So this video is just, the only purpose this video serves is to show you the level of quality and video data that you can get from using drones versus traditional methods. Apologies. Moving on. So, what does the future hold? Quite simply put, the future in drones, in the drone industry, is quite literally limitless. If you were to ask anybody involved in the drone industry a decade ago what they think the drone industry would look like 10 years down the line where we are now, I don't think half of them would have been able to envision the level at which the drone industry has developed to this point. So now the next question is, what can we look forward to in the future? Well, currently there is a worldwide push for the use of drones in the logistical industry, the delivery of supplies, medical supplies, parts, equipment, documentation, whatever you can think of, using drones instead of traditional vehicle methods, as well as the use of fully autonomous drone systems, using AI-controlled drones to do the inspection instead of manned interfaces. So, I mean, these are some of the things that we are currently exploring. And when we say future, we say within the next foreseeable year to 2 to 3 years. We're not even looking that far ahead down the line. Personal mobility is also becoming a big thing. I know a lot of guys are working in what we call the eVTOL industry, where the use of personal air taxis in large metropolitan areas is also going to be a big player in the market. But focusing specifically on the oil and gas industry, what our vision for the future is providing a total safe and autonomous solution to our clients, with the overall goal of minimizing cost, minimizing safety risks, and minimizing overall logistical implications for the client. So giving you the opportunity to concentrate on what is important, which is growing your business in a sustainable manner. So that's about all that I have to say on the subject. I would like to open the floor for anybody who might have any questions or any clarifications that might be required.
All right. Thank you very much, Petrus. That was a very informative presentation, I believe. So we will now open the floor for questions. So guys, please feel free to type your questions into the chat box or the Q&A window, and we will address them one by one, inshallah. So we got 9 questions so far. So we will start with the first one. The first question, Petrus, what is the range in kilometer of a BVLOS drone?
Okay, yeah, I mean that it depends on the system that you use. You can get anything from some of the, I want to call them the less expensive BVLOS drones, can fly anywhere between 30 to 50 kilometers away from the central operation base. Other drones, like the ones we use, can fly up to 2,000 kilometers away from base. It all depends on the system that you choose to use, and also obviously the infrastructure available to you. Some drones have the ability to connect and be controlled via satellite uplink. Other drones use traditional radio wave methods. Some drones have interfaces with 3G, 4G, and 5G networks. So it's all dependent on which system you use. But currently, in the commercial sphere or commercial drone operations outside of the military, anywhere up to 2,000 kilometers, I think, is a safe and doable distance.
All right. Next question is, do you get real-time streaming or wait until BVLOS drone returns? So is there any live streaming option?
Yes, of course. The video that I showed earlier about the flare inspection and the inspection of the oil, this is all real-time live streaming that is viewed and operated by the payload operator. Some payloads on the aircraft itself, like the still images and the photogrammic high-resolution images, are saved on board the drone and is processed once the drone lands. But yes, of course, real-time streaming is very similar to what people, I want to say, what people see in the movies. We have the capability of having a live view of any video that we record using the pod.
All right, perfect. Third question, do your team use any OGI camera?
Yes, we do. We do have a OGI. We have a specific brand of OGI camera that we use for detection of specific gases, and we are always looking at innovation specifically in that area. So we have identified several key players in the development of OGI cameras. So currently the market isn't very saturated with available solutions, but we have a very reliable OGI system that we use at the moment. We are currently exploring additional units that have that are a little bit more sensitive with a higher resolution.
Okay, fourth question. The 600 kilometer to 800 kilometer quoted is for one drone or considered based on multiple drones being deployed?
So the ranges are calculated per aircraft. So you can have multiple aircraft flying at the same time, but each individual aircraft is capable of reaching these distances on their own. It's not limited to multiple aircraft.
Okay, fifth question. What type of gas detection the drones are fitted with? Methane, CO2, H2S?
Yes, to answer the question is the OGI camera that we currently use can detect methane, CO2, and H2S. It's all dependent on the payload itself. You can have specific payloads geared at a specific mission or a specific type of quantification or detection, or you can have universal cameras that detect various types of gases. But there are very, very few noble gases on the periodic table that aren't detectable by OGI at this point in time.
All right, moving to the next question. How can BVLOS drone data be utilized for surveying and mapping?
Well, that's the most interesting part. So I don't even know where to start with this question. So how do we use the data? We have several payloads that are geared specifically towards surveying and mapping. We have high resolution photogrammic cameras, still images. We have LiDAR for topographical surveying. All these data is concatenated using post-processing and turned into very high resolution, very, very accurate mapping data with ground resolutions of up to, I think, 1.5 to 2 centimeters in some cases, with a very, very high degree of accuracy. So we are seeing a big shift in the industry, especially in the Middle East, where people are moving away from traditional surveying missions using traditional methods where guys on the grounds driving from point to point in favor of using drones, because drones are able to provide the same data, but at a much lower cost, at the same accuracy level, at much higher resolution, with more available data, not limited to only topographical, but as well as photogrammic as well. So we can use them quite extensively. In fact, this is the biggest growing industry when it comes to drones is surveying.
Okay, next question. What are local regulations on BVLOS? Is approval same as VLOS?
Now that's a tricky one. Currently, specifically, I'm talking specifically about Oman at the moment. I'm not talking about any other country. So just please don't take my word as gospel. But the law in Oman is very clear when it comes to BVLOS operations. You need to have very specific approval from the Civil Aviation Authority, as well as the NSA, to do BVLOS operations, which we obviously have. In order for you to get the approval to do BVLOS operations, it is a very, I want to say tedious process, but that's not the correct term. It is a lengthy and comprehensive process involving risk assessments, proof of concept, the specific manuals and the way you handle data. There are so many regulations that you need to comply with before you get the final approval. So BVLOS operations are currently only allowed under commercial operations with specific pre-approval from the relative authorities. VLOS, to my knowledge, I don't think visual line of sight flying is 100% legal for private individuals currently in Oman. I do know that VLOS operation, because we have a very large VLOS operation as well, follows roughly the same process where you need to have specific approvals from the governing authority, from the Civil Aviation Authority. And these approvals are based on so many factors. Like I said, proof of concept, proof that your maintenance, your operation, your training, your HSE, your environmental health and safety, all of that is specifically geared towards the operation and meets the minimum safe standard as required. And these regulations are changing on I would almost want to say, a monthly to a yearly basis this point in time. So it is important for anybody in the drone industry to have a very good relationship with the governing authority and make sure that you comply with the relevant regulations at all times.
All right. What's the extent of inspection that can be taken by BVLOS drones?
Just unmute here. The extent, or like what is the there is really very low limit to what you can do. I mean, we can do anything from bird nest inspections to power lines, road infrastructure, oil wells, gas pipelines, oil pipelines, water infrastructure, environmental inspections, for example, encroachment of specific species. We can look at the overall conditions of wadis. We can do coastal inspections. There is very, very few limits to what can be done with BVLOS drones.
Okay, can you give an indication of the financial impact of using drones instead of traditional inspection methods using real financial data?
Well, I don't have actual access to our company's real financial data, so I won't be able to share that, but I can give you the general industry benchmark based off of quoted sources that I'd be more than willing to share at the end of the presentation with everyone. Let me use a real world example, and then you can do the calculation for yourself. Let's take oil and gas pipeline inspection specifically. So let's say we have to inspect a pipeline that is roughly 500 kilometers away from us. So for you to do that with a traditional method is you need to deploy a team. This normally takes the form of a two-man team in a vehicle that need to drive 500 kilometers to the site. And at that point, they don't even know the exact location. They just know the rough area. So these are two people driving a vehicle, most likely a diesel-powered vehicle, SUV, for a distance of 500 kilometers. So that takes, at an average speed of 100 kilometers an hour, that's about 5 hours of driving one way. And another 5 hours of driving another way. They have to stop every 2 hours to rest to comply with HSE guidelines. So now you've essentially lost 10 to 12 hours of man hours times two, because it's two people. Remember, it's not one. So you're essentially losing 24 man hours to inspect an area roughly the size of 100 square meters. Whereas with the drone would have been able to fly that distance in 2 hours, if even. Fly the distance for 2 hours. This is one pilot and one payload operator, and you don't always need the payload operator. You can get away with just the pilot. You have a pilot flying 5 hours to a location, 2 hours to a location. It inspects the area with pinpoint accuracy, process the data real time, send it to the client while the drone is flying back, automated on its own back to base. So you've turned 24 man hours into essentially 4 man hours at half the cost. You've cut out the cost of fuel, transportation, overall maintenance of the vehicle. You've cut down the cost of the required simple things like PPE required by the crew, meals, accommodation, all of that goes away. So using that example, you can quantify that real world. But to give you percentages, drone operations versus traditional methods, we've been able to cut costs up to, in some cases, up to 70%.
Okay, what is the reliability of onboard OGI sensors considering wind and high surrounding temperature? And be quick, Petrus, because we have too many questions to answer within the remaining time.
All right, let me make it quick. Again, using OGI sensors to inspect something, it all comes down to the pre-flight planning. If you need to inspect something at a time of day where the temperatures exceeds the limitation of the equipment, then obviously you plan your flight to take part or take place in either early morning, late afternoon, depending on the environmental factors. So you still need to be very cognizant of the environmental factors. But these same limitations apply to traditional methods as well. So it all forms part of the pre-flight planning.
Okay. Usually, what optimal kilometer coverage per day for pipeline inspection?
Standard linear pipeline inspections, it all depends on how many hours you have available to you and if you have day versus night operations. But during day operations, we currently do upwards of about 8 hours of flying. So we cover roughly between 500 to 1,000 kilometers of pipeline that can be covered per day.
Okay. The next question. When you say 2,000 kilometer, what is the duration of flight?
The duration is dependent on the performance of the aircraft. Is it a hybrid drone that uses both battery and fuel-powered systems? Is it a solely electrical powered drone? It depends which system you have. So we have drones that can fly upwards of 140 kilometers an hour. We have drones that fly slower than that, between 50 to 70 kilometers an hour. So it depends on which drone we use. But to cover 2,000 kilometers at 140 kilometers an hour, you can do the math. It's very simple. You're looking for 2,000 kilometers of flight time. You're looking at about 10 to 12 hours of flight time.
Perfect. Next question. Can you share the operational challenges that you're facing in conducting BVLOS operations?
Yeah, so the biggest operational challenges that we have currently is training. So because BVLOS drone operations is very much in its infancy worldwide. When I say in its infancy, it means there's very few companies and very few countries that have BVLOS operations to the scale that we do. So finding competently trained personnel is, I think, one of the biggest challenges. That's why we have implemented a very stringent and robust in-house training process that is also approved by the relevant authorities. So training, the acquisition of competent staff, that's number one. Number two is environmental factors, temperatures, wind, etc., etc. And then the third one, I think, which is probably the most difficult, is convincing the relevant authorities to allow the operations to happen, because we're talking about something very new. And sometimes new things are scary to people who have been used to operating in a traditional sense. So the three major challenges that you will face in any BVLOS operation is training/crew acquisition, getting the approval from the relative authorities, and the environment.
Okay. What about the takeoff and landing area for the BVLOS drones? Is there a specific area or requirement area to maintain the drone's safety during flight?
Yes. So again, this comes down to depending which system that you choose to use. If you have a VTOL drone, which stands for vertical takeoff and landing, you can basically take off and land from anywhere, as long as it's a flat, open surface, and it's clear of any debris. Some of our drones use traditional linear takeoff methods, meaning that we operate from airports. So they take off from a specific airport, they fly to the location, do the mission, and come back. Other drones are deployed from the field, where we have a team deployed to a central location in the field. They take off and then they fly in a 50 to 100 kilometer radius based off of the location where they are. So it all depends on which system you use.
Okay. The next question is, any payload you have for pipeline BVLOS check, such as depth of BVLOS? Any payload you have for the pipeline BVLOS check, such as depth of BVLOS, like the buried pipelines, for example?
I'll have to check with our data team. I'm not sure about that question.
As of now, the only thing that we have is the GBR sensor. It's a ground penetration radar, where we can detect the buried pipelines within 5 meters under the ground. However, this cannot be used using the BVLOS at the moment.
Yeah, that is correct. We also have the potential to do UD, where we use VLOS drones to measure the thickness of pipeline walls as well as tank walls. So that's also one of the payloads available, but currently also not in BVLOS at the moment, unfortunately. Sorry, Ibrahim, before you move on, I see one of the people asked, do you go through the SORA process for pipeline inspections? Yes. So even though SORA, which just for everybody who doesn't know, SORA is the specific operation risk assessment. It is essentially the risk assessment process used by EASA, or the European aerospace industry, to determine the safety of drone operations. So even though there is no laws in the GCC, specifically in Oman, that require us to use SORA, but for our own peace of mind, as well as for that of our clients, we use the SORA methodologies and framework when we do risk assessments for all our drone operations, not limited to only BVLOS, but as well as VLOS. So we do follow what we like to call the industry standard when it comes to the safety of our drone operations. Okay, go ahead, sorry, Mary.
Okay. Someone was asking about the palm disease. Are we able to use the BVLOS in pesticide spraying?
Yes, of course. In fact, the agricultural industry is one of the fastest growing drone industries currently operating. In fact, there are some places in the world, which I cannot mention, unfortunately, at the moment due to sensitivity, but there are places in the world where using traditional methods of spraying pesticides and herbicides have completely been outlawed in favor of using only drones and or aircraft. Here in Oman, we have a sister company called Wakan, who is currently using drone technology for the spraying of pesticides, herbicides, as well as pollination of palm trees, etc. So yes, there's definitely a very, very big scope for using drones in that regard, especially with the new range of DJI Agras drones. They're all BVLOS capable, able to fly up to 20 to 30 kilometers away. So yes, definitely.
Okay. Next question. How do you overcome the limitation of the network in terms of some areas if you are considering live streaming?
So we have invested heavily in what we call a MIMO mesh network across large portions of the country, which allows us with very high fidelity, strong radio signals that we control our drones with. So we currently don't face that issue too much. There are certain areas and certain times of the day where we might have intermittent video connection, but that is few and far between. One of the ways that you can overcome this, if you're willing to invest in the infrastructure, is doing it the same way we did, by investing in a fully comprehensive MIMO mesh network. If you don't want to do that, you can go with traditional SatLink. So there are some drones on the market that use a SatLink interface that allows you with high fidelity streaming using satellites in terms of your data connection, which minimizes the overall loss of signal. So I know with the expansion of the Starlink network, these are going to become much more popular moving down the line. In fact, we foresee in the next 2 to 3 years that very few drones would still use traditional radio uplink, and we control solely using SatLink uplinks.
Okay, you mentioned about cracking detection. So the question is, how precise is that from your previous experience in terms of size, length, and if a history of assets is given, what is your insight on this?
Okay, so it's important to give some clarification on this. So when we say about crack detection, it depends on the mission profile. If we fly low enough using the high resolution cameras, we can definitely detect specific sizes of cracks in pipes. And then what we then do in these instances is then we identify the specific area to a very exact point of where the crack is, and then we direct a manned team on the ground to go inspect it visually and, if necessary, do the repairs in real time. Cracks are one of the few things that we're limited to. If it's a microscopic or a small crack, it's very difficult to detect with a camera. to be fair, it's also very difficult to detect by eye. So the purpose of BVLOS drones is to identify the specific locations of where issues arise and then flag that area for human intervention, where a repair team or an inspection team can go to a specific location. So what we mean by that is, instead of having a team drive up and down the pipeline the whole time trying to find problems, we do that part for them, minimizing the overall cost and safety risk, etc. And then if we do discover a problem, we still need human intervention, where we identify the problem location with pinpoint accuracy, and thereby decreasing the amount of time between detection and actual repair. So I hope that answers the question.
I hope so. So next question, what is the spatial resolution of methane sensor you are using? Well, the current OGI that we are using can detect the gas leak as low as 60 grams per hour. And please make sure to know the difference between the gas leak detection and gas leak quantification. For detection, you're only detecting the gas leak itself. For quantification, you are quantifying and knowing the amount of gas leak, right? So next question, what about the takeoff and landing area for the BVLOS? Is there a specific area? I think you already answered this question, right? Before?
Yeah,
All
no,
right.
it depends on the system again, yeah.
Okay, moving to next question. Can BVLOS be used to detect ground surface deformation caused by oil extraction?
Yes, definitely. Using advanced LiDAR payloads, we can definitely, to be very clear, all these things that you're asking about are done during post-processing. So for the purposes of data acquisition, BVLOS allows us to acquire the necessary data much faster than traditional methods. But yes, so using both advanced photogrammic sensors as well as LiDAR sensors, we can detect ground deformations due to oil extraction.
Okay. How will a remote pilot handle a route change or a route change? They don't have visual line of sight, BVLOS. What are the procedures for emergency landing in such situations?
That is a very, very good question. So all of our drones are programmed with what we call fail-safe systems. So in the very unlikely event of the loss of C2 link or command and control link with the drone itself is able to detect that it has lost, apologies, it has lost connection with the ground control station. And in that case, the drone goes into fail-safe mode, where it would climb to, in our case, it would climb to a predetermined altitude and then immediately return to base. If the drone has lost all forms of power or connection, there's very little that you can do. But our drones are programmed to use onboard sensors to land, in the unlikely event this happens, to land in an open area that is free from built up from people, buildings, all of that. So it looks for the flattest surface that it can find, and then it initiates a safe, what we call the controlled descent.
Okay, next question. What is the leak detection threshold in a gas pipeline? Well, to be honest, as I said before, we have to differentiate between the gas leak detection and gas leak quantification. And I believe it's better to elaborate more on your question by submitting a question form on our website. So feel free to elaborate more on your question, please. Next question, does BVLOS get affected by the same weather conditions as BVLOS?
In some instances, yes, but in most instances, no. So let me clarify. BVLOS drones are susceptible to high winds only during the takeoff and the landing phase. But while the aircraft is in flight at the altitudes that they fly at, the wind has very little effect. The biggest issue that VLOS drones have is high winds. And because you fly so low to the ground, high winds will always affect the accuracy of the aircraft. VLOS drones are also very susceptible to something that we call the KP index, or solar radiation, which degrades the overall quality of the GPS signal. Unfortunately, VLOS drones are susceptible to this, but very fortunately, BVLOS drones are very seldomly affected by this. And I also saw one of the questions that sort of ties into this is, do we experience jamming from time to time? Lucky for us, again, depending on which system that we use, our drones are fitted with what we call multiple GNSS systems. A lot of people think that the word GPS is the same as GNSS, and it isn't. GNSS refers to the system, which GPS refers to specifically to the GPS system controlled by the US government. So our drones are fitted with systems that can either use GPS, that is provided by the US, or Beidou, which is provided by the Chinese. We can use GLONASS, which is provided by the Russians, as well as Galileo, provided by the Europeans. So should we experience jamming based off of one system, the aircraft is smart enough to just simply use data from the next system that is not experiencing jamming at that time. So no, we have been very fortunate that we have not experienced GPS jamming here in Oman as of yet.
What are BVLOS/VLOS drones available with digital twin capability?
Yes, some of them are. However, the digital twinning is, again, it's one of those technologies that is also very much in its infancy at the moment. I know there's a massive push by some industries to use virtual reality and virtual environments for the control and operation of BVLOS drones. There are several companies in the West that are experimenting with that, but we were fortunate enough during our last visit to the world's largest UAV expo in Shenzhen in China to have a very long conversation with several companies that are pioneering this field of technology, where they want to use VR environments, virtual reality environments, and digital environments for the control and data acquisition using BVLOS drones. So it is growing. Nothing commercially available at the moment, mostly experimental, but it will get there if we another year to 2 years, and it will be a very viable part of the drone industry.
Okay, there is a great question. What are your thoughts on airship drones?
Sorry, you broke up again there. Say a little bit again.
Someone is asking about the airship drones, if you have any thoughts.
Airship drones in terms of the ones used to transport people. I'm assuming that's what he meant by that. Look, I come from a manned aviation background. I used to be a pilot for many years. Based off of that, I would be very hesitant to fly in an aircraft where the pilot is somewhere else in the world. But that's my personal background. I know a lot of people are very excited about the use of airship drones, and I think if all the problems and all the gremlins are worked out of the systems, definitely, if they follow the same approval and evaluation processes as manned aviation, then I can see no issue with them. But from a personal standpoint, I wouldn't fly in an aircraft if I'm not in control of it. I hope that answers the question. I see, sorry, just Ibrahim, I see another question. Have we used the Oman Course Net for precise GNSS positioning? To my knowledge, we have not yet. But that's an interesting question. I think I'll explore that a little bit more, and then hopefully we can, through social media, we can definitely provide an answer to that question. Please go ahead, Ibrahim.
Okay. Does your MIMO network cover the oil and gas central region areas?
Yes, our MIMO network covers the majority of central and northern Oman, with current plans to expand to southern Oman. So yes, it covers a very, very vast area.
Okay, the next question, I think you already answered it previously. Do you have flight jamming from time to time?
No, we have no. No, we've been fortunate not to experience jamming as of yet. We have in that regard, part of the approval process of using BVLOS drones in Oman is we have a very good working relationship with the Royal Oman Air Force, as well as the ROP, the Royal Oman Police. So they are the only people I think that would be concerned with jamming drones, but we have not experienced drone jamming.
All right. Last question. Someone is reposting the buried pipeline depth detection question. So as we said before, As of now, we have only the GBR sensor, ground penetration radar, which can detect any pipeline within 5 meters away from the ground. So this is what we have at the moment. However, we are exploring other sensors as well. When it comes to the VLOS and BVLOS, as of now, we are using only the VLOS method. However, we are doing some research on using the BVLOS or long-range drones for buried pipeline detection.
There you go.
Okay. I think we have one more question. Have you used Oman? I think you already answered this one, right? All right.
Yes.
So it looks like we have covered all of your questions, guys. So Petrus, is there anything else you wanted to cover before the wrap-up?
Yeah, of course. I would like to reiterate to everybody on the panel, everybody joined us today. I want to say thank you again for giving us your time. Look, the future is changing, and it's changing at a rapid rate. Drones are a very real part of that future, and it's important that we use sustainable solutions like UAV or drone technology to try and optimize traditional methods. We are not for 1 second proposing moving away completely from using tried and tested traditional methods, but we would like to reiterate to everyone that sometimes innovation is for the best, and especially in our industry where safety is critical, there is no safer operation than a drone operation. So we would like to make sure that people understand that this is the future, and there is really no way of moving away from that. But again, I want to thank everyone for joining us today and taken the time to listen to us in regards to what we had to say. Ibrahim, over to you.
Thank you, Petrus. Great. So we appreciate you being here today. Please note that this webinar will be uploaded on our YouTube and LinkedIn pages at the soonest, of course. Also, please feel free to contact us through the communication channels provided. If you have any further inquiries, please use the channels again. Thank you again for joining us today, and we will see you next time, inshallah.